G'day folks, welcome. Today we're going to be looking at conditional probability. When we first started probability, I made a big deal about telling you that probability only has one formula. Right? And there is. I wasn't kidding, I'm not going to pull a Swifty and change that on you. Probability only has one formula. The probability of something happening is the number of ways that it can happen divided by the number of possible things that can happen. Right? That formula that I gave you when we first started is still true. The reason why we don't do probability back then in like year 3 when we first learned to count, or year 2 or whatever it is when we first learned to count, is because counting itself can be a very, very difficult problem. Okay, I've spoken about this before in class. If I was to come along and present a problem to you, the thing about that problem that makes it difficult, the thing that makes it challenging, is that the way I express myself makes it hard to count the things that I'm talking about. So we see this in particular in this case known as conditional probability problems. So what's a conditional probability? Well, what does the word condition mean? Well, the condition is sort of something that is happening in a particular place, in a particular time, in a particular way, right? A particular condition, if you like. So I might say, look, the chances of catching, I don't know, a flu are pretty low. But in certain conditions, that might be pretty high. So it might be really old, or it might be like very, very young, or it might be immunocompromised, or whatever. Okay, so the conditions change the number of ways that a thing can happen. Okay, the conditions change the number of possible things that can happen. Right? So our probability still stays the same. It's the number of things that can happen over the number of possible things. The number of ways the thing we want to happen over the number of possible things. That doesn't change. So what changes is how we work out how the conditions impact on that. I'm going to start just by giving you a couple of formulas straight up, and we'll always be able to come back and rely on these formulas. But all these formulas are a way of getting down to that sort of bare bones. The probability of an event is the number of ways the event can happen divided by the number of possible things that can happen. Okay, so let me give you an example of a place where we use a conditional probability, and then I'll put the formulas up so they make sense. Let's say that I do a survey of all the people in our class, and I say, how many people here like tennis? And some people put their hand up, whatever. Some number of people put their hand up. So, okay, how many people like rugby league? And some number of people put their hand up. If I was to say, if I was to pick a person at random from our class and say, what's the probability that this person likes tennis? Well, that's easy. You find out how many people put their hand up for tennis, how many people are in the class, and the first number divided by the second number. What if I was to say, well, given that I'm looking for people who like rugby league, what's the probability that if I pick a person who likes rugby league, that they will be one of the people who like tennis? Okay. Well, now I'm putting a condition on what it is I'm talking about. So given that the person has to like rugby league, what's the probability that they like tennis? That changes the question, yeah? So it's a case of a conditional probability. Given the condition, person likes rugby league, what's the probability they like tennis? So the way we set out our calculation for this is with this notation. We say that the probability of A given B, so the probability that somebody likes tennis given that they like rugby league, in the example I just spoke about, well, that equals the probability of A intersection B. Now what does intersection mean? Intersection means both and. Okay. The probability of A intersection B divided by the probability of B. Now look, I'm not going to hurt your heads by getting you to go through and work out why that formula is true for now. Let's just work with it a heck of a lot of times and become very familiar with it. And then, looking back, the penny will drop itself, right? Why this formula is true will drop itself. And likewise, if I was to reverse this, so this is a particular order, this is the probability of A given B. That's different to the probability of B given A. Okay? So if I was to say, given that I'm only going to pick from the people who like rugby league, what's the probability they like tennis? That's different to, given that I'm only going to pick from the people who like tennis, what's the probability they like rugby league? It's a different condition. Right? So if I was to reverse this, the only thing that would change for the probability of B given A is the probability of A intersection B. So the top of my fraction doesn't change, but of course on the bottom, now I've got the probability of A there. So my given condition, its probability is in the denominator. My given condition, its probability is in the denominator. That's a good way to remember it. Okay. Now there's an even simpler way to look at this, and that's that. I'll rewrite the formula. I'm not just going to extend this. So one way, if we know the probabilities, or if we can calculate the probabilities, or we can simplify these formulas down to what I'm about to put down. So you might want to get those down. So pause the video if you like and get these down. I'll come back in just a second through the magic of video editing, and I'll come up with a simplified or a simpler version of these. I'll be right back. Okay, welcome back. So what's different? What's different? What I'm looking at now, I'm not looking at the probability of A intersection B or the probability of B. I'm saying, well, how many elements are in A intersection B? How many elements are in B? Right? So it's a lot simpler, a lot easier, oftentimes, way to work it out. And same deal, if I reverse my conditions, well, then I'm looking at the number in my condition. Right? Now, the question has really now just become one of comprehension. Right? We need to be able to read the question, realise what it's saying is the condition. So over here A is the condition, over here B is the condition. Once we can, and it really is, it becomes a reading comprehension problem, not a mathematics problem. Once we can comprehend what the question is talking about, we come back to our formulas and we calculate probabilities. So let's have a look at an example. Again, through the magic of video editing, I'll come back with a problem on the board, and we'll have a go at solving that one. I'll be right back. Righto folks, welcome back. So in this example, I've got a Venn diagram showing A and B. So we've got, in A altogether, we've got 5 plus 2, so there's 7 people in A, or 7 elements in A. In B, there's 2 and 6, altogether there's 8 elements in B, and there are 3 elements that are in neither A or B. And we're going to answer these 5 questions to come up with, well, ultimately we're really working towards answers to part 4 and 5, where we say what's the probability of A given B in this scenario, and what's the probability of B given A. Right, so let's start from scratch. Let's start from the very beginning. So the probability of A. So what does that mean? That means that if I was to come along randomly and put all these elements in a box and shake them up, and I reach in and I pulled one out, what is the probability that I pull out something from A? Well, the probability of an event is the number of ways that event can happen over the number of possible things that can happen. How many A's are there altogether? Well, there are inside the A circle, there are 5 here and 2 here. There are 7 things altogether. So the probability of an A is 7 divided by the number of total things that can happen. Well, how many total things can happen in my Venn diagram here? Well, 5 and 2 is 7, and 6 is 13, and 3 is 16. So there's 16 total things that can happen. Right? So the probability of A is 7 out of 16. Let's keep on going. What's the probability of B? Well, the probability of B is the number of ways B can happen. So there's 2 and 6. There's 8 possible B's in our set, right? So the probability of B is the number of ways that B can happen, 8 over the number of possible things that can happen. And again, the number of possible things that can happen, just like it was over here, is 5 plus 2 plus 6 plus 3 is 16. Okay. And if we want, we can simplify the fraction. So that's just going to be 1 over 2. Let's keep on going. What's part 3? The probability of A intersection B. So the probability of A intersection B means something is both and A and B. So what's both A and B? Well, that's this 2 over here. So the probability of A intersection B is the number of ways that A intersection B can happen, which is 2, divided by the number of total things that can happen, which we've already seen is 16. So that's 2 over 16, which is 1 over 8. Let's keep on going. Now we're finally up to calculating our conditional probability. I'll just make sure my computer is still awake. So the probability of A given B. We'll now recall our formula. If you just look up on your page that you're copying all this down on, you'd have, that's the probability of A intersection B divided by the probability of B. Well, this is going to be 1 over 16 divided by 1 over 2. Okay, I'm going to continue my working out. I'm going to just erase over here and continue working out up here. But no, I won't. I'll leave that because I need my probabilities to refer back to. So I'm just going to erase this bit over here. So this is going to equal, so just sort of continuing from down there, continuing up over here. The probability of A intersection B is 1 over 8. Divided by the probability of B with 1 over 2. We're dividing fractions, we invert and multiply. That's going to work out to, you can put that in your calculator if you like. I'm just trying to save a little bit of space here. If you need help with the calculation, let me know and I'll show you how to do the calculation. It's going to be 1 over 4. So the probability of A given B is 1 out of 4. Okay, where was I? Sorry, okay, the probability of B given A. So part 5, the probability of B given A is, we're going to use our same formula, the probability of A intersection B divided by the probability of A. Well, A intersection B, remember, was 1 over 8. The probability of A was 7 over 16. So when we invert and multiply there, let me just do that one in my head. Sorry, I can't do that one in my head. Sorry, yep, okay. That's 2 over 7. Okay, so the probability of B given A is 2 over 7. Okay, let us have a look at how these things actually play out using the other version of the formula, right? So not the version of the formula that uses probabilities, but the version of the formula that uses numbers, right? The number of elements in the set. So the probability of A given B would have been the number of things in A intersection B. So the number of things is 2 divided by the number of things in B. Well, that's 8. 2 over 8, of course, is a quarter, which is what we had over here. The probability of B given A is the number of things in the intersection, which is 2, divided by the number of things in A, which is 7. So it's 2 over 7. So both ways could work. We need to be able to have our Venn diagram set up anyway. And in an exam situation, folks, you're probably going to be asked to find the probabilities. But it's good still to have access to both of those formulas. I'm going to ask you to go to page, if you haven't already done so, to go to page 156 and copy out the key ideas on the bottom of page 156. And then after that, I want you to go to page 158 and work on exercise 3D. Okay, I'd like you please to do all of questions 1 to 6. Now there's a lot there, but I think it's really important that you sort of get a lot of this sort of practice under your belt. Because, as I said, a lot of this conditional probability stuff is really a comprehension activity. We get good at comprehending when we basically immerse ourselves in that sort of speak, you know, that sort of lingo. So I want you to go there and I want you to do all of questions 1 to 6, please. Any questions, guys, you know what to do. Get in touch with me. I'll be happy to help you out. Thanks very much.